Now see here the linear magnification. You know the linear magnification is represented by small m and it is equal to the ratio of height of image to the height of object. That can be written m is equal to h dash upon h. So, this is the formula for linear magnification. Linear magnification has no unit, but by knowing the linear magnification or the value of m, we can tell whether the image is real, inverted or the virtual erect, or we can say whether the image is larger than the size of the object or the smaller than the size of the object. So, now let us derive relation for this, where this one is the linear magnification in terms of the image distance and object distance. Suppose you have taken concave mirror like this and this point is known as the pole and this is F here, this is the C and object is here, suppose that is A and B. We take one incident ray like this, after reflection it will pass through the focus. Another incident ray we take like this, which is coming and striking at the pole, and after reflection it is going in this way, that is reflected ray. Image is obtained here, that is A dash and B dash. This will be the angle of incidence I and this is R, these two are equal. So, now if you take triangle we can write here triangle ABP is similar to triangle A dash B dash P. So, we can write AB upon A dash B dash is equal to BP upon and that is here B dash P, or we can write here A dash B dash upon AB is equal to PB dash upon PB. Now, see here in this relation we can see and we can write here also, here that is A dash B dash is the height of the image, but it is the below this principal axis downward to the principal axis. So, it is taken as negative and we can take that symbol is minus h dash. AB is here h height of the object, that is only positive because it is perpendicularly upward to the principal axis. And then we can write PB dash, that is the image distance, it is minus V, and PB is object distance, that is minus U. So, now we can solve it. Further we can take the relation in another form. We can write here or minus h dash upon h is equal to V upon U, or we can write h dash upon h is equal to minus V upon U, and we know this thing h dash upon h is m. So, we can write m is equal to minus V upon U. So, this is also relation for the between the height of the object and image distance and object distance, and this is the relation between the magnification, object distance and image distance. So, just by seeing the formula of the magnification you can decide the nature of the image.